Hi guys, and welcome to my laboratory, which happens to be my kitchen. And your kitchen can be your laboratory too with parental guidance. Be sure you always ask your parents before you start messing with things in the kitchen. But today I want to show you an example of a chemical change. A chemical change. And I'm just going to use things that I really have around my house. And one thing I had to go and buy, but I'll show you my supplies. And anytime you do an experiment, especially one that's going to involve a chemical change, you want to have some equipment, like a lab coat maybe. And you don't have to have a lab coat, maybe dad's old shirt or something to protect your clothes. But then always, always, no matter what, you want to wear safety goggles. Okay, and you can get these at Dollar Tree. So they're not expensive, but you want to protect your eyes because you never know, especially in a science lab or in a science kitchen, you never know how things are going to react to each other. That's what we'll talk about with chemical changes. You never know because you can take something that's not harmful and add it to something that's not harmful, and you mix those together and have a reaction, so they might become a little harmful, maybe explosive or something like that. Sometimes, like we talked about in class today, you could take something that by itself would be perhaps harmful, like sodium and then chlorine, which is a gas. But you know what? When you mix those together, you get something that you sprinkle on your French fries, and that's salt, table salt, sodium chloride. So it's pretty cool, but you always have to have somebody with you when you're doing an experiment, and you want to be safe. So I've got my lab coat, got my goggles, and I'm ready to go. Let me show you what supplies I've got. And I followed, it's almost like a recipe. Doing an experiment is almost like a recipe. You've got ingredients, and you follow particular steps, so you'll know that it's going to turn out correctly. So my equipment for today, let me show you. I just basically have a pan. Thank goodness I bought some for Thanksgiving, so this is a perfect pan because I can throw it away when I get finished. And then just an empty bottle, and you want to rinse it out. You want to make sure there's nothing left in there that might change your experiment in any way. So an empty bottle. This is just a Diet Coke bottle. And then my experiment called for a funnel. That's one of the lab tools we talk about. I think we'll talk about those next week. So a lab tool, or in a couple of weeks, a lab tool. And then it calls for some food coloring. Mom probably has this in her pantry. Use it with permission. This you'll probably find by the kitchen sink like I did. Some Dawn dishwashing detergent. Does it have to be Dawn? Not necessarily, but Dawn works very well. So Dawn dishwashing detergent. And then probably something you don't have in your pantry, and that is a particular concentration of peroxide, hydrogen peroxide. And I actually bought this from a beauty supply store, like you go buy shampoo and hairspray and stuff like that. So this probably you don't have in your pantry, but this is something you would have to use with mom or dad or grandma and granddad anyway. So some peroxide, and I have it measured out. Another tool, and I'm going to be very careful because I already have it measured out, but I want to show you. I have measured 1/2 cup, and you can see that. I have it on a paper plate. I have 1/2 cup of the peroxide. Okay, so I have that measured out. It's very important when you're doing an experiment that you measure precisely. Okay, and then for our elephant toothpaste that we're making today, I also need yeast. This is something you're going to smell probably when you smell bread baking or something like that because it has yeast. It causes bread to rise. So I have a yeast mixture. So those are my supplies that I'm going to use today. And again, you know what? Yeast, that's not harmful really. There's no reaction going on there. And really the peroxide is just kind of sitting in the measuring cup. So, you know, it's really not doing anything now. It is harmful to me. I wouldn't want to smell it. And that's one thing, you never put your face over a science experiment. Anything you're doing, because it might burn your eyes, it might burn your skin, you might breathe it. So we never just put our faces to smell something. So I know peroxide is in there, but by itself, you know, it's just kind of sitting there. Food coloring, doing okay. But what I want to show you is when you mix things up, and we're going to talk about molecules of atoms, you know, atoms, those basic building blocks. But why reactions happen like chemical changes, okay? And you're going to see when you just take some normal things and add them together that some really strange but cool things can happen. All right, so let me see. So I'm going to follow my experiment directions, and I've got my empty bottle. It's clean, got my empty bottle, and then it says to add 3 to 4 drops of my food coloring to my peroxide that I have mixed, that I have measured out. And you know what, guys? If it says 3 to 4 drops, use 3 to 4 drops. Don't change the experiment. You want to make sure that you're 1, 2, 3, 4. I did put 4 because I want it to be dark, so you can imagine what that's doing. Okay, so I've added my 3 to 4 drops of food color into my peroxide. Now what I'm going to do, I'm going to pour that. I want to pour that into this bottle. But you know what? If I start to take my measuring cup and try to get all of that into this bottle, that's going to be a little tough. So I'm going to use one of my lab tools, which is a funnel, which will help to pour that mixture of my peroxide and my food coloring into the bottle without spilling it. Okay, so let's see. I'm going to have to change hands because I'm right-handed. And you know what? I want to do everything possible not to make a mess, not to spoil my experiment, and not to have a mess for me to clean up later. So I'm going to pour this is my peroxide and my food coloring. And I'm going to put this into the bottle. And look how nice that goes into the bottle by using a funnel. I didn't spill a drop. Okay, so in my bottle, this is what I have, peroxide and food coloring. And you know what? There was no reaction between the food coloring and the peroxide. It just changed the color of the peroxide. Okay, so here's my funnel. I better get that out of the way. And I want you to be thinking, now why would she put this in the pan? Think about that. Think about that. Now the next thing it says to add my dishwashing detergent. And you know what? I need to pay attention. How much dishwashing detergent? It says that I need a squirt. Not sure that's a true measurement, but you know what? I'm just going to put a squirt. That looks about like a squirt. Okay, so there's my squirt. I may just tilt that a little bit to get that done. And again, no reaction. So if I mix dishwashing detergent with peroxide, I have no reaction. You can tell it's just kind of a mixture, in other words. Okay, so I have my peroxide. I need to make sure I've got everything, my food coloring, and I have my Dawn dishwashing detergent. The only thing I have not added is my yeast. Again, I want to use my funnel. Now, I'll tell you, yeast comes dry in a package, and what you do, you mix it with warm water, and then it becomes like a liquid instead of a solid. And so now I want to pour, and I want you to make sure that you can see this bottle. I'm going to pour the yeast mixture into my peroxide solution, and I want you to see if you can see a reaction. Oh, yes, I think we might have a reaction here, guys. Look, and what we have just made, let me get a little closer to the camera, is elephant toothpaste. Elephant toothpaste. Can you see it? Does that not look like toothpaste that you're squeezing out of the tube? Okay, so now you've seen a chemical change. You've seen a chemical reaction, actually, because the yeast has caused some kind of reaction in there. And guess what? We'll get to this a little bit later. Well, actually, you'll get to this in a couple of grades. But an oxygen has been released, okay? And it has to do with those molecules in there, the atoms. And we'll talk about that. But you just saw me make elephant toothpaste. I'm going to tilt my camera just a little bit because I want you to see. And if you were here, if you could feel this, you know what? This is as warm as it can be. Heat has been released, okay? And that happens often with a chemical reaction. You would not believe how warm this is. And none of that was warm when I started out, okay? None of that was warm when I started out. So here you have, we don't have a peroxide anymore. You can't even see any liquid falling out. You have elephant toothpaste. So if you see an elephant walking by that has some dirty teeth, you're going to know what to do with it, okay? Well, guys, I hope you enjoyed that experiment, and we'll do some more experiments with things that you can do at home, but let me remind you, never, ever, ever try an experiment without your parents' permission, without your parents being there. Thanks for listening.